Students, welcome back to my video class. Let us continue the discussion of symmetry elements. I hope you have watched my first video. Symmetry element is a special kind of topics. It will be understood. Only you should follow the videos as per the syllabus, as per the system, as per the continuation. Otherwise, you will feel the difficult. Therefore, my first request is watch the previous video, then come to this topic. Okay, I have designed the topic so as to qualify the basic understanding, so as to get the basic understanding, as well as helping you to attempt the questions in JAM, GATE, NET, JRF examinations. Okay, and I need your support. You subscribe and share my videos so that other students can also benefit from the classes. Okay, today I go to the plane of symmetry. Last classes we discussed the axis of symmetry. It's an imaginary axis which is passing through the center of the molecule, and it is represented by Cn. N is the order of the rotation. We have two types of axis: principal axis and subsidiary axis. Okay, today we can go to the plane of symmetry. What is the plane of symmetry? It is represented by sigma. Plane of symmetry, it is the imaginary plane passing through the center of the molecule, comma, the molecule or edge and the molecule is symmetric along both sides of the plane. Okay. Yes. It is an imaginary plane passing through the center of the molecule, and the molecule is symmetric along the plane of the molecule. Normally we consider three types of plane. One is this. Look at this plane, both. I said to you, this is x-axis, this is z-axis, and this is y-axis. Therefore, this plane is xz plane. This plane is xz plane. Okay. Now suppose you have another plane like this. A plane like this. Okay. What is this axis? This is your y-axis. Therefore, this plane cut z and y. This is yz plane. Okay. Therefore, normally we consider these two planes, xz plane or yz plane. We have one more plane like this. That is called a xy. Not like this, then like this. Okay, I will simply show you here. Okay, 1, 2. Then dividing that two. That is xy plane. That's quite difficult anyway. Therefore, please, for time being, this is enough. Xy plane, yz plane. Yes. Now, I will say to you one example. For example, this is water, this is HOCl. I draw a plane like this, that YZ plane, that plane like this, YZ plane like this. Simply, you see, like this. Okay. Now, what is the plane of symmetry means? Plane of symmetry means imagine this part. This is your plane. This part is hydrogen. Suppose it is a mirror. This plane is a mirror. Imagine. What will reflect here? Here will be a H. What is the reflection here? Here will be H. Is that H is here? Yes. Therefore, we can say this molecule has this type of a plane of symmetry. Whatever, suppose you keep a mirror here, whatever the reflection on this mirror is here, whatever the reflection on this mirror is here, you can say this molecule has a plane of symmetry like this. But it does not have a plane of symmetry like this. Why? Because I keep a plane like this. What will be a reflection here? Hydrogen and hydrogen. Does hydrogen and hydrogen here? No. Therefore, this molecule has no plane of symmetry in this direction, but it has a plane of symmetry in this direction. Fine. But if I keep a plane here, what shall be the reflection on this mirror? Cl. But what is originally seen here? H. Therefore, this molecule has no plane of symmetry like this or like this. Okay. That is why I say the molecule is symmetric along the side of the plane. Yes, it is symmetric. That is why whatever reflected on this mirror is here, therefore it is also called a mirror plane. Students, it is also called a mirror plane. Plane has another name is called a mirror plane. Whenever you read any textbooks, when you see this idea, that is mirror plane, don't confuse. That's why it is called a mirror plane. Okay. Let me check the video. Yes. Now, types of mirror planes or plane of symmetries. Types of planes. Next topic is types of planes. Planes classification. That is, one is vertical plane. That is represented by sigma v. Another one, horizontal plane, that is called sigma h. Another one is diagonal plane or dihedral plane, sigma d. Dihedral plane, sigma d. Vertical, horizontal and dihedral planes. You have three types of planes, plane of symmetries. What is a vertical plane? Vertical plane is nothing but plane containing principal axis Cn. You know what is Cn. That is, suppose this is your principal axis, suppose z axis, and you have a plane, an xz plane like this, Therefore, this plane is called sigma v, because this xz plane containing principal axis. I said xz plane is this board, z axis. Okay, or it can be like this also, no problem. Or it can be like this also. Axis can be z or x that contain the plane. Here the plane perpendicular to Cn. Perpendicular to Cn. Suppose this is your axis. This is your axis, z axis. Now your plane is YZ plane. Look at here. YZ plane. Plane is YZ. This is called sigma h. Sigma h. Another one is diagonal, very rarely it is seen. It is a plane bisect to C2 axis. Be careful. It bisects two C2 axes. Okay? Suppose you have two C2 axes. C2 axis, you know what is C2 axis? One C2 axis is y direction. Another C2 axis is in z direction and y direction. Okay? Y direction. And you have a plane which is bisecting. Suppose you have two axes like this. Okay? Okay, two axes like this. Now what is bisecting means a plane like this, cutting. A plane like this. Okay, which cut these two axes. Look at here, it cuts. This is axis, this is, it cuts like this. Am I correct? Cutting. It cut here, it cut here, and going like this. Okay, a plane like this. Is it clear? Okay, fine. That is cutting like this. That is called a diagonal plane. One example for this molecule is our water. Water, because you have a plane like this and you have an axis like this. One example for this is, I will be air, planar molecule. Am I correct? Planar. You have an axis like this. Okay? You have a plane containing, suppose, imagine boron here, fluorine here, one fluorine here, one fluorine, or this molecule, or platinum here, Cl here, Cl here, Cl here. Therefore, molecular plane. You have a plane like this and an axis. Fine? We will discuss more. Here, one example is xenon F4. By heart the example. Okay? Xenon F4. Here BF3 or platinum Cl4 2 minus. Here water NH3 etc. Okay? Therefore, we have vertical plane containing principal axis, horizontal plane perpendicular to CN axis, diagonal plane. It's a plane which bisects two C2 axes. Now, I will give you some tricks. Most important planes are horizontal plane and vertical plane. Horizontal plane, sigma. This trick, remember, horizontal plane normally seen by linear and planar molecules. It is seen by this type of a molecule, like linear molecule, carbon dioxide, then BCl3, platinum Cl4. Planar means triangular planar, square planar, then octahedral, SF6, because they have a planar part. Sigma V is containing pyramidal or bend shapes. Okay. Now, again classification based on sigma H and sigma V. Classification based on sigma V and sigma H. First, molecules having sigma V only, molecules having sigma H and sigma V. Very careful about it. This is my again my trick. For 99%, if there is a sigma H, there will be sigma V. If there is a sigma H, there will be sigma V. Therefore, you check first sigma H. If there is sigma H, there will be sigma V. If there is no sigma H, there may be sigma V. Here the example H2O, NH3, PCl3. Okay, there it has 3 sigma V, it has 2 sigma V, it has 3 sigma V. Here BF3, it has sigma H and 3 sigma V. Platinum Cl4, sigma H and 4 sigma V. Okay. Benzene, very careful example, sigma H and 6 sigma V. Because benzene also planar molecule. Okay, it's a planar. Yes. Now I give some examples. We can discuss some example here. First, ammonia. NH3. Where is its sigma V? Ammonia. Ammonia, I said to you, it has a C3 axis and 3 sigma V. Ammonia, 1, 2, 3. The structure of ammonia will be like this. Like this. You please, students, please remember, all these are equal. Hydrogen, hydrogen, hydrogen. It has a C3 axis like this. It had a C3 axis like this. Okay. Now, you imagine a plane which containing sigma planes. It has no horizontal plane because it is not a planar molecule. Only planar molecule has a horizontal plane. Horizontal plane is a plane which containing atoms, all atoms, which is perpendicular to the. This is your axis, horizontal plane like this. If you do not have this type of a plane, you do not have this type of a plane. Okay. Suppose you keep a plane like this. I said you imagine a mirror. What will be the image in this mirror? That is not found in the here. Okay, but it has a plane like this. Plane like this. It cuts. Okay. Now this molecule will not be there because it is within the plane. Now what is after the plane? You getting like this. Okay. Yes, you are getting like this. Both sides are right. Whatever the image on this book, that is here. Whatever the image on this side, that is here. Therefore, it has 3 sigma V's. It has 3 sigma V's. This is our ammonia. Therefore, it has 3 sigma V. 1 sigma V here, 1 sigma V here, 1 sigma V here, all containing principal axis theta. Therefore, ammonia has 3 sigma V's. Okay. Now we can go to next example. Next example, BF3. BF3. Students, what is BF3? It's a planar molecule, trigonal planar. Okay. Trigonal planar. Imagine the molecule is in the plane of the board. It is like this. B on the board, F on the board, this F on the board, this F on. As you see. Therefore, it has a principal axis like this. Axis like this. Now, this board is a plane. How could be it is a plane? That's very important understanding. You have a plane like this. You have a plane like this along the board. This is called sigma H because it is perpendicular to principal axis. Now your question, how could be that plane? Yes, it is plane. This is also called a molecular plane. Molecular plane. Molecular plane is the plane. Molecular plane is the plane which contains all atoms of the molecule. All atoms of the molecules. All atoms of the molecules. Because you have 4 atoms, all atoms are in the plane. All atoms are on the board. All atoms are fixed on the board. And board is a plane. Now, what is this side? This side of the plane? Nothing. What is the other side of the plane? Nothing. Therefore, it has a plane of symmetry. Because whatever reflected, I said to you, whatever reflected on this board of this side, whatever reflected on this side, nothing. Therefore, here it has a molecular plane. Every planar molecules have a molecular plane. Keep in mind this sentence. Every planar molecules have a molecular plane. This molecular plane is perpendicular to the principal axis. Therefore, this molecular plane is horizontal plane. Fine. It has an horizontal plane. That is a molecular plane. Don't make it a conclusion that every molecular planes are horizontal plane. No, I didn't say like that. I didn't say. Probably it can be. All molecular planes are, all horizontal planes are molecular plane. Don't say it like that. But you take that every planar molecule has one molecular plane. It may be horizontal or anything else. It may be horizontal or vertical. Anyway, that's we have to explore again. Now it has horizontal plane. Now it has vertical plane. Vertical plane means it's a plane which contains principal axis. This is your principal axis. Suppose I have a plane like this with the principal axis. Plane like this. Included. What is this side? F. What is this side? F. Therefore, it has one sigma v this side. It has one sigma v this side. It has one sigma v this side. It has how many sigma v's? 3 sigma v. Therefore, it has a C3 axis. And it has a 3 C2 axis. It has a C2 axis. Please watch the earlier videos. It has sigma h. It has 3 sigma v. Fine? Yes. Now we can go to another example. Another example. That is platinum Cl planar. It has C4 axis like this, C4 axis. It has sigma h, that is molecular plane. It has 3 C2 axis, last class, sorry, 4 C2 axis. It has how many? Look at it. It has a plane like this, including principal axis. One C2, one sigma v. It has another sigma v, second sigma v. It has third sigma v because 2Cl, 2Cl. It has 4 sigma v. Okay, therefore it has 4 sigma v. If there is a planar molecules, in the case of planar molecule, it has principal axis and sigma h, then 99% it will be 4C2, 4 sigma v. 4 sigma, 99%. Okay, now we can go to another, with one more example. I will stop this discussion. SF6. SF6. What is a sulfur? Fluorine. 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 Okay. Fluorine. Fluorine. Simply we can say like this. Okay. Yes. Sulfur center. Fluorine, 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 fluorine. One sulfur here also. Okay. Fluorine, 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 fluorine. One sulfur here also. Fine. It has a principal axis, C4 axis through Z axis, that is from here to here. An axis passing from this fluorine to this fluorine, that is principal C4 axis. You can rotate like this. It has a horizontal plane. Suppose this plane, book plane, that is consisting of 4 fluorine, 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 fluorine. It is a plane because upper side is fluorine, lower side is fluorine. And that plane is perpendicular to your principal axis, C4 axis. Therefore, this is its horizontal plane. Am I correct? This is its horizontal plane. Okay, it has C4 axis, sigma. Now it has how many C2 axis? 4 C2 axis perpendicular. How many sigma v? 4 sigma. It has 4 sigma v. Okay, it has 4 sigma v. One will be this side, second will be this side, third will be this side, fourth will be this side. Sigma v like this, sigma v like this, sigma v, third sigma v like this, fourth sigma v like this. Okay, yes, I hope it's understandable. And you come to my comment box, share your doubts, we will discuss there. Okay, thank you for watching.